Hello everyone. Today we are going to see about the hormones which involves in the maturation process. So first, maturation is the process by which the fetus is born. So at the end of the pregnancy, the uterus begins strong rhythmic contractions by which the fetus is expelled. So the mean duration of the human singleton pregnancy is 280 days, that is about 40 weeks, from the first day of the last normal menstrual period. So we have to know some term which is defined as the period from 37th weeks to 42 weeks of gestation. So in this the preterm means the delivery before 37 weeks of gestation, and postterm means the pregnancy continuing beyond 42 weeks. So what are the causes of uterine contractions? So there are two things that causes the uterine contraction. First one is the progressive hormonal changes, and second one is the progressive mechanical changes due to the enlargement of the fetus. So in this, the hormonal changes that increases the uterine contractility. So the progesterone estrogen ratio. So during pregnancy, progesterone and estrogens are secreted. So from the seventh month of the pregnancy onwards, estrogen to progesterone ratio is balanced. But after seventh month, that is about 30th week, estrogen reaches its highest level and stimulate the formation of oxytocin receptors on uterus. And progesterone level drops off and stimulate the beginning of contraction that will lead to birth. So corticotrophin releasing hormone. So it's a hormone which is a peptide hormone released by the hypothalamus, but it is also expressed by the placental and chorionic trophoblast and amniotic and decidual cells. So in the second trimester, that is 16th week onwards, the placenta is the major source of corticotrophin releasing hormone secretion. So the CRH stimulates the pituitary ACTH secretion and adrenal cortisol production. So in the mother, the cortisol inhibits the hypothalamic CRH and pituitary ACTH release, creating a negative feedback loop. So in contrast, cortisol stimulates the CRH release by the decidual, trophoblastic and fetal membranes. And this CRH further drives the maternal and fetal HPA activation, thereby establishing a potent positive feedback loop. That is the positive feedback loop. And in normal pregnancy, the increased production of CRH from decidual, trophoblastic, and fetal membranes lead to an increase in circulating cortisol beginning in the mid gestation. So the effects of this CRH are enhanced by a fall in maternal plasma CRH binding protein near term. Activation of the fetal HPA axis results in enhanced fetal pituitary adrenocorticotrophin hormone ACTH secretion that leads to the release of abundant C19 estrogen precursor dehydroepiandrosterone dione sulfate DHEAS from the intermediate zone of the fetal adrenal. So this is because the human placenta is an incomplete steroidogenic organ, and estrogen synthesis by the human placenta has an obligate need for C19 steroid precursors. So this DHEAS is converted in the fetal liver to 16-hydroxy DHEAS and then travels to the placenta where it is metabolized into estradiol, that is E2, estrone E1 and estriol E3. And it also enhances the prostaglandin production from chorionic, amniotic and decidual cells. And the CRH also can directly affect myometrial contractility. Other actions of CRH includes dilation of the uterine vessels and stimulation of smooth muscle contractions, dilation of the fetal placental vessels via NO synthetase activation, and stimulation of prostaglandins F2 alpha and prostaglandin E2 production by fetal membranes and decidua. So these are all actions conducive to the initiation of the labor. So this corticotrophin releasing hormone is also stimulated by the inflammatory cytokines. So the next hormone is the estrogen. So the placenta is the primary source of estrogen, and concentration of estrogen increases with the progressing gestational age. So the human placenta lacks cytochrome 17, needed for the conversion from progesterone to estradiol. The fetal zone of the adrenal gland produces DHEAS, and it is hydrolyzed into the 16-OH, that is hydroxy DHEAS in the fetal liver. So this 16-hydroxy or DHEAS may be aromatized by the placenta to produce estriol, which is the major circulating estrogen of the human pregnancy. So in contrast to the non-pregnant state, during late human pregnancy, the ovary is a minor source of circulating estrogens. And estradiol and estrone are synthesized primarily by aromatization of maternal C19 androgens, that is testosterone and androstenedione. And whereas estriol is derived exclusively from the fetal C19 estrogen precursor, that is the DHEAS. And this estriol concentration in serum and saliva increase during the last 4 to 6 weeks of pregnancy. Then these estrogens promote a series of myometrial changes, including increased productions of prostaglandin E2 and prostaglandin F2 alpha with augmented expression of prostaglandin receptors, increased receptor expression of oxytocin, alpha androgenetic agonist with moderate membrane calcium channels, increased synthesis of consin and gap junction formation in myometrium, and upregulation of enzyme responsible for muscle contractions like myosin light chain kinase, calmodulin. So all these changes allow coordinated uterine contractions. The next one is the progesterone. So this stimulates the beginning of contraction in uterus, which leads to the birth. So corpus luteum is the source of progesterone till 7 weeks of pregnancy. The placenta takes over the functions at approximately 7 to 9 weeks of gestation. In pregnancy, progesterone is in dynamic balance with estrogen in the control of uterine activity. So the animals demonstrate systemic progesterone withdrawal as an essential component in initiation of labor. So humans, though, do not so fall in circulating progesterone. There is growing number of evidence that spontaneous onset of labor is preceded by a physiologic withdrawal of progesterone activity at the level of uterine receptors. So, in vitro, the progesterone decreases the myometrial contractility and inhibits the myometrium gap junction formation. So, on this progesterone activity, it stimulates the uterine endosynthetase, which is a major factor in uterine quiescence. And progesterone downregulates the prostaglandin production as well as the development of calcium channels and oxytocin receptors, where this both calcium channels and oxytocin receptors are involved in the myometrial contraction. So the calcium is necessary for the activation of smooth muscle contraction. So in the cervix, progesterone increases tissue inhibitor of matrix metalloproteinase 1, which inhibits the collagenolalysis. Thus, it is clear that progesterone is a major factor in uterine quiescence and cervical integrity. The factor that results in parturition must overcome the progesterone effect that predominates during the early pregnancy period of uterine quiescence. The activity of 17,20 hydroxy steroid dehydrogenase in fetal membranes increases around the time of parturition, leading to an increase in net 17 beta estradiol and 20 dihydroprogesterone. So this is a factor in altering the estrogen or progesterone balance. There may be decreased progesterone receptor levels at the terms, resulting in a diminished progesterone effect. Prostaglandins, they stimulate more contraction of uterus. So these prostaglandins are formed from the arachidonic acid that is converted to prostaglandin H2 by the enzyme prostaglandin H synthetase. So this prostaglandin H synthetase is an inducible form of the enzyme. So cytokines increase the concentration of this enzyme 80-fold. So prostaglandins are degraded by 15-hydroxy PGDH. Then prostacyclins. They are the inhibitory prostaglandins present throughout the early pregnancy and are also responsible for the uterine quiescence during pregnancy. Although prostaglandins may not be obligatory for labor in knockout mice, they are of major importance in women. And these prostaglandins are produced in the placenta and fetal membranes. So prostaglandin levels are increased before and during labor in the uterus and membranes. So in this prostaglandin 2 alpha, okay, so it's produced primarily by the maternal decidua and acts on the myometrium to upregulate the oxytocin receptors and gap junctions, thereby promoting the uterine contraction. And prostaglandin 2 is primarily of fetal placental origin and is likely more important in promoting cervical ripening associated with the collagen degradation and dilation of cervical small blood vessels and spontaneous rupture of the fetal membranes. And many factors affect the production of prostaglandins. Levels are increased by progesterone and increased by estrogen. So several interleukins results in an increase in prostaglandin production. Then next one is the oxytocin. So it is released by the fetus and mother's posterior pituitary gland, and this oxytocin bind to oxytocin receptors on uterus and stimulate the powerful contraction on smooth muscle of uterus. So oxytocin stimulates the release of prostaglandin E2 and prostaglandin F2 alpha in fetal membranes by activation of phospholipase C. So it induces the myometrial contractions through phospholipase C, which activates the calcium channels. So next, last one is the relaxin. So it relaxes the structure in preparation for delivery, and this is a peptide hormone. It has three main actions. They are promotes rupture of fetal membranes, then allows softening and dilation of cervix. Then it weakens the pelvic ligaments, allowing stretch of the female pelvis. Thank you.